All right, let's go over the chapter 6 test. Okay, first thing is to convert 7 radians to degrees. Now, if you're converting, you're either going to multiply by 180, which is degrees, which is the same as pi radians, or you're going to multiply by pi radians over 180 degrees. Since I said it was 7 radians and you're trying to end up with degrees, radians, you need the radians to cancel. So that what you multiply has to have radians in the denominator, so the units cancel. So we got to put pi in the denominator and 180 in the numerator. So we got to take 7 times 180 divided by pi, and we get 401.0704566. 0.70456. And we want to keep more units than usual, because when we go to degrees, minutes, seconds, that's quite a bit of decimal places. Okay, the degrees are obviously 401. It says so. But this is what makes the minutes and seconds. So we take the 401 and subtract it, so we can work with that decimal, and that's a fraction of a degree, and a degree is 60 minutes. So we multiply by 60, and we find out that's 4 minutes. And the rest of it's a fraction of a minute, so I subtract the 4 minutes. And there are 60 seconds in a minute, so we multiply this by 60 also. And we find out it's 13.64 seconds. Now, I'm going to go back. Here's what we did originally, and here's the angle in degrees in decimal form. And for those of you who have the graphing calculator, there's a conversion under angles. Second apps. Change the answer to, number 4 says change the answer to degrees, minutes, seconds. So if I select it, it'll change that automatically to 104 degrees, 4 minutes, 13.644 seconds. I left off one of the 4's, but there's it is. All right. So now we got to reverse the process. Well, we know we got 32 degrees. And we got 3, now there's 60 minutes in degree, and we got 3 minutes, so we got 3/60ths of a degree. And there's 60 times 60 seconds in a degree, which is 3,600. So we got 54 hundredths of a degree, 54 3,600ths of a degree. Now, on the sample test, I gave you a negative angle, which means it was going some degrees and then some minutes more in the negative and some more in the negative. But this is a positive angle, so it's going 30 degrees plus some minutes plus some seconds, and these are all positive, so you should not have subtracted. You need to understand when you add or subtract. So we should have typed in 32 plus 3 divided by 60 plus 54 divided by 3,600. And that comes out to 32.065 degrees in decimal. And now we're going to convert it to radians. So we have degrees. We want that to cancel, so we multiply by the ratio that has degrees in the denominator, pi over 180. So we're going to take 32.065 times pi divided by 180. And that comes out to be times pi divided by 180, 0.559638. Okay? All right. Get the exact values. Well, it says the square root of 2 times the tangent of 45, and from our quizzes you should know the tangent of 45 is 1. Then it says minus 4 times the cosine of 5 pi over 6. Okay, tangent of 45, that's right there where the sine and cosine are both square root of 2 over 2, and so that's why it's 1, sine over cosine. But the cosine of 5 pi over 6, 5 pi over 6 is 30, 1 pi over 6, 60, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. The cosine is the long side of the 30, 60, 90 and negative, so that's negative square root of 3 over 2. And 4 times something over 2 reduces to just 2 times it, so we get 1 times the square root of 2, or square root of 2, and a minus times a minus is plus, and the 2 reduced into the form leaves a 2 times the square root of 3. Okay, now I saw on number 4, please do not do this. People wrote cosine of 2 radians over cosine of negative 2 radians, and they crossed out the cosines. Cosine is not something that multiplies by it. That is a bunch of malarkey. You cannot cross them out. So what can you do? Well, if you think about what 2 radians are, that's on the circle, it's how far the radius goes twice. Once, twice. So we're over here for 2 radians, and the cosine's this number, the x direction of 2 radians. Then it says the other angle is minus 2 radians, 1, 2, so that would take you the same, symmetrically the same over here, and the cosine of that will be the same number. And so these two numbers, which are exactly the same, they're both negative, are the same, would divide, and we would get 1. The other way you could look at it is, remember that cosine was even. It doesn't care whether the angle is positive or negative. So you can ignore this angle, and you'd have cosine of 2r over cosine of 2r, which is 1. Five. Many of you said, okay, I know from the video or from what we learned that we've got to do sine squared of the angle plus the cosine squared of the angle has to be 1. And you said negative 3/5 squared. Some of you said negative 3/5 times negative 3/5 is 9/25. And some of you just said it was negative 9/25. You should be smart enough at this level that negative 3/5 times negative 3, a negative times a negative is a positive. Some of you rely on your calculator. You typed in negative 3 over 5 squared and you get something weird, unless you put the proper parentheses around all of that. Anyway, plus cosine squared of the angle has to be 1. So we subtract 9/25 from both sides and we get cosine squared of the angle is, well, see, 1 is 25/25 minus 9/25. And some people have trouble subtracting 9 from 25, and they get things like 14 instead of 16/25. And then you take the square root. And some of you said, I don't care if when you take the square root that it's plus or minus. I'm just going to use the plus one or the minus one or whatever. You take the square root of both sides and you get the cosine of the angle is either the plus or the minus. Square root of 16 is 4. The square root of 25 is 5. However, it says right here that the tangent has to be greater than 0. If the sine is negative 3/5, that means it's down 3/5. You got to be in this quadrant or this quadrant. And if you go in this quadrant where the cosine is positive, the tangent would be the sine divided by the cosine. That'd be a negative divided by a positive. The tangent would be less than 0. So it can't be in this quadrant. It has to be over here where the cosine is negative. So the correct answer for the cosine of the angle is negative 4/5. And the tangent is a positive number. It says right here it has to be positive. The sine, negative 3/5, divided by the cosine, negative 4/5. And I'm hoping by now you've figured out if they both have the same denominator, you can multiply by 5 and 5 in the numerator and denominator, cancel them, and you get negative 3 over negative 4. And a negative divided by a negative is positive 3/4. And the secant is reciprocal of the cosine, so that's going to be still negative 5/4. That's the first page. Page 2. The absolute value of this coefficient, the number out in front, and I'm going to write this bigger so you can see it, y equals 4 cosine pi over 2 times x minus 0.5, close both parentheses, minus 2. The amplitude is the absolute value of the number in front, so it is 4, and most of you got that. The period is, for cosine, is 2 pi divided by the number in front, which is pi over 2. To remove this, we multiply by the reciprocal, 2 over pi, the reciprocal, so that those cancel, but I have to multiply the numerator by 2 over pi. So I get 4 pi divided by pi, which is 4. So, with those two things, and it says, is there any translations? Yes, this curve, there's an subtract 0.5 on the x, on the inside. Subtracting from the x moves things horizontally and opposite what you think, so it will make it, move it to the right 0.5. And then on the outside there's a minus 2. That's subtracting 2. It's not times this stuff, and so that's going to move it down 2. So, if the amplitude is 4 and it's down 2, the center line is down 2. Now, many of you can't get the units straight on the graph, and that really drives me nuts. But you need to go to your graph, and since you got to go down 2, figure out how far down 2 is. Some of you do it by single squares. I'm going to go by 2 squares so you can see it on the video, so I'm going to go down 2 squares for minus 1, another 2 squares for minus 2, get your units on there, down to the 2 squares for minus 3, another 2 squares for -4, another 2 squares for -5, etc. And get them going this way. 1, 1, 2 squares. Some of you had 2 squares, 3 squares, 5 squares, whatever. Doesn't work. You're not going to get credit for this if you can't get your units and spaced evenly, etc. The period is 4. So we shouldn't be marking off horizontally by pi's. It's supposed to be by 4 units. So I'm going to go by 2's again. There's 1. There's 2. 2 more squares is 3. 2 more squares is 4. I'm going to have a complete cycle by 4. Okay, so we got that. Some of you couldn't get that, and that just destroyed your answers. Some of you did some pretty good stuff after that, but messed that up. All right. Now, it's moved down 2, so our center line is -2. Many of you drew the center line. I think that's great. And many of you said the amplitude's 4, so I'm going to go 4 above. Not 2, 4, 4 units above. So from -2, if you go up 4, that'd be -1, 0, 1, 2. And that will be the top of the curve. And then you got to go 4 below the 2, which is down here at -6, just off the graph. That's the bottom of the curve. We've got to touch both of those lines. Amplitude is how far above and below the center line. Okay. Now we're doing a cosine curve. And on the unit circle, the cosine at 0 degrees is 1. From our quiz, 1. And then 1/4 of the way through the period's 4, so 1/4 of the way it's at 0, -1, 0, 1. So it's at 1 at the beginning, it's at the top, but now our amplitude's 4 and we're starting from down, so it's at the top. And then at 1, it's at 0. Then it's down at on the center line. And then clear down at the bottom at the next one. And then back on the center line at the next quarter. And back at the top at 4. And that would be great, except that this was shifted. -0.5 moves it right 0.5. Now I got 1 on there, so I know exactly how much 0.5 is. It's 1 square over, so it's got to be there, and not at 1, not on the center line at 1, but 1.5, half a unit over. Not on -6 at 2, but 2.5. Not back on the center line at 3, but 3.5. And not back at 4 at the top, but 4.5. Each one of those is 0.5 over. So I should be drawing it, this was not it, down through the center line, down to the bottom, back up through the center line, and I should see each of those 5 points. And I should see the same 5 points going backwards. The top, and 1 unit over, since it's 4 for a whole cycle, 1/4 of the way, 1 unit over, I should be on the center line. Another unit over, I should be down at the bottom. Back on the center line. And back at the top. And I'm looking to see all those points located on the graph. Correct units on the axis, not on the center line. You can put them on the center line, but I want them on the axis. Correct units that are evenly spaced on the y-axis. If you don't do that, I can't give you credit. Okay, now I asked, what's the pi over 2 do? And that adjusts the period to 4. What's this? And it was supposed to be 0.5. The negative 0.5 shifted the graph, the curve, right 0.5 units. What's the minus 2 on the end do? It takes the whole graph down 2. And what's the 4 do? It makes the amplitude, or the distance above and below the center line, and it's the center line that's in the center, 4 above it, 4 below it. Okay, that was this one, worth 2, 4, 6, 8, 10, 12, 14, and 4. 18 points on that problem. I really want you to know how to do that well. All right, the tangent. You still need to know all the key points of a tangent. All right. I didn't put any number in here to change the period. So the tangent period is normally pi, and it will be still pi. The 3 is sort of the amplitude, and the center line is up 1. So I'm going to put some units on my graph. And now I want to put vertically still 1, 2, 3, and I can do that every 2. So there'd be 1, 2. Get your units on there first. 3, 4, 5. Down 1, down 2, down 3, down 4, down 5. Now horizontally, since the period is pi, and I don't want to get it crammed up too tight here, I might make this a quarter pi, half pi, 3/4 pi, pi out here 4 squares, or maybe 8 squares. But whatever I put it at, then figure out spacing for more. So then if I go further, another 4 squares, that's where 2 pi should be. Some of you had all kinds of spacing on that. Make sure they're evenly spaced. If I go pi there, then 2 pi would be out here. Now this would be easier to see if I'd actually done half a pi either side, because the tangent is a full pi, and that's 2 pi now from there to there. Let me go ahead and do that. So I'm going to make this pi over 2, and so then this would be exactly pi. So now my tangent curve, which has a width of pi, will go from minus pi over 2 to pi over 2. And remember that on the unit circle, the tangents, as the angle goes up, it's how far on this line. So by the time I reach pi over 2, when the angle gets up to pi over 2, it's undefined. And I didn't adjust the period, so it's going to be pi over 2. An asymptote. It doesn't reach that line. And negative pi over 2, the same thing. If you go to negative pi over 2, it doesn't hit the line that's the tangent line. The other thing you should remember from the unit circle is if you go to a 45 degrees, halfway between 0 and pi over 2, pi over 4, it's 1. But it has an amplitude of 3 times that. So here's the center line. Remember, it was up 1. And the tangent is 0 to start with, so it'll be on the center line at 0. It was on this to the origin, but we're going to be up 1. There's nothing here to make this tangent go upside down. The tangent's positive in the first quadrant, so as I go this way, it's positive. And if I go all the way to pi over 4, halfway to pi over 2, it's 1, but it's times 3, so it's up 3 above the center line. So I'm going to be looking for you to look right at halfway between where it's on the center line and the asymptote to be up 3 units higher. 1, 2, 3. Learn how to find that point. And if I go back halfway between where it's on the center line and the asymptote, it should be that quote-unquote amplitude below the line. 1, 2, 3, which is down here at -2. And then it goes off to the asymptote. It goes through the center, through that one, and off asymptotically. And that will repeat. I'm looking for you to have correctly labeled axes. I'm looking for you to have the center line. I'm looking between where it crosses the center line and the asymptote that you've done the correct amplitudes and you've done the correct curve. This problem was worth 6. All right. Just like when we graph it, when we go back to the equation, we've got to know the same information. This graph is a little hard to read, but it says -5 where this curve reaches the bottom. -5. The height that is at the top is at 1. So the center line must be halfway between, which is -2. So I know at the end of my equation I have -2 to lower the whole curve down. Now, the next thing I want to do is the amplitude, and I see I have an amplitude. It goes from 1 to -5, that's 6, but the amplitude's half of that. Goes 3 above and below the center line, so I got 3. And now I have to decide whether I'm going to do sine or cosine. And so I'm going to look at the center line, and I see right away that it crosses right on the center line on the y-axis at -2. The curve that crosses through the origin or on the center line is the sine, so the easiest would have been to do the sine. But the sine normally goes up. As you go around the unit circle, sine starts at 0 and goes positive first. Goes up. But this is going negative. So I can either do a negative angle, or I can just say flip it over. Put a -3 on it. Next thing was the period, and several of you messed up on that. Looks like it goes from a little over -3 to a little over +3. If you look at it carefully, that looks like where it's crossing. Now, some of you called the period 6. That's half of the wave. The period is 12, but actually it goes from -pi to pi. So that's -pi to pi is 2 pi for half of the wave. The other half of the wave would be another 2 pi. So the period is actually 1, 2, 3, 4 pi. And you can get that by putting 1/2 in front of the x. Because then you would take 2 pi divided by 2, and you would have 4 pi. Now, some of you put pi over 6 there. That's like a little over 3 divided by 6, which is about 1/2. So that would have worked. I accepted that because it also kind of looks like it goes from -3 to 3. It's actually 3.14. So this is everything we need to have this curve. It is not shoved sideways. If you had decided to use cosine, it would have been shoved sideways. So you would have had a +3 or 3 point something. And you could have written, and that wouldn't have had to been flipped. And so you could have written y equals 3 cosine half, and then parenthesis x. To move it back, you would have to go +3 or pi, something like that, -2. The center line is still down 2. So that would have worked also. That one was worth 8 points. This one's worth 8 points. Some of you weren't very careful at looking at how high this line. If you make a line connecting the bottoms of these, it's at 1.5. So that's the top of the curve in between, 1.5. And if you carefully draw a line across the tops of these, it's at -2.5. So the center line must be halfway between those. If you add those, you get -1 divided by 2. The center line is at -1/2. So we have -1/2 or -0.5 on the end of our equation for the center line. And we have an amplitude that goes from -0.5 to 1.5, which is an amplitude of 2. And we have a curve that starts on the center line, goes up to the curve, down to curve, and back onto the center line by pi. Well, a curve that starts on the center line goes up is a sine curve. And the sine curve normally has a 2 pi period. This only has pi. So we have to take 2 pi and divide it by 2. So it has to be 2x. And that would be the equation of this curve inside here. And since this is reciprocal of it, to get rid of those asymptotes, so that would be y equals 2, reciprocal of sine is cosecant of 2x minus 1/2. Now there's some other things you could have done to get it, but that would have been the easiest. All right, the final problem. Okay, a quick sketch of this will tell you that it starts in January, and of course we all know that the daylight hours in January are not very much, 9.17, and it grows from there to a peak in June of 15.88 hours. And the lowest is not the 9.17 but the 8.52 on December again. Then it starts up again, December 3rd, around the 21st. That's when the equinoxes are, and the summer solstice, and the start of winter, around the 21st of the month. That's why I said these are all the 21st of the months. And so our low is about 8.52. So if our high is 15.88 and our low is 8.52, if we subtract those, we get 6, 3, and 7. Half of that, since that's the high, that's the low, the center line is halfway between there. I mean, the amplitude is half of that. So if I divide that by 2, that would be 3.68. 3.68. So my amplitude should be 3.68. The center line is halfway between these numbers, so I should take the 15.88 divided by a plus 8.52. So that's 10, carry the 1, that's 13, 14. Carry the 1, that's 16 and 8's 24.4. Divided by 2 is 12.2. So this graph is up 12.2. Now, question is, are we going to do sine or cosine? And you can do it with either. The calculator, if you do this, if you put this data in the calculator, will give you the sine graph. But this looks like an upside down cosine the way it's laid here, where this is 1 and 0, 0, which would take you back another month, is pretty much close, right on 0. December, and then January being 1, December would be 0, or the 12th month, but it loops around, so and December was the lowest, so you really don't have to move this curve sideways very much at all. If you do the cosine upside down, and then you have to make it have a period of 12 months, 12. And so you would write 2 pi divided by 12, which is pi over 6x. Now, if you decided to shift that slightly, the calculator shifts it a little bit, but that's close enough. That would have given you a good enough equation for it. If you use the calculator to get it, let's see, I don't think I have the data in the calculator. Let me see if I can find somebody here that has it. There we go. See if this person doing it on the calculator. Yeah, the calculator gives you 3.601 sine, so just about the same amplitude. It used a positive, it said sine, which starts in the middle. Well, this curve's over here, so we'd have to move it this way, so we'd have to subtract some. And said a pi over 6, which is a little bit, about 0.5, it uses 0.51 is what the calculator gives you. X minus 1.485. So to actually know how much it shifts sideways, I'd have to take and divide this by 0.51. To factor it out, it'd be 0.51 times x minus, and I'll do on 1.485 divided by 0.51, and it says shift the sine curve about 2.91, about 3 months. Well, 3 months, if this 3, 6, 9, 12 months, so if we shift it, the sine curve, which starts on the center line like this right here, if we shift it, it goes minus, so it says shift it 3 months over to make the sine curve land on this, about. And it gives, the calculator gives a center line of 12.147, which is about 12.2. So the calculator did a similar curve. It just used the sine instead of the cosine, which fits this pretty well. Okay?